Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today my guests are from Intel. We have Andrew Flint and Carolyn Hanley. Welcome to the show today, folks.
Thank you.
Thank you very much.
I brought your slides up. Why don't we start there, and we'll do Q&A at the end.
Perfect. So starting off on slide 3, and we'll talk a little bit about how I came to Intel. I'm the product manager here for our cache software. This came to Intel, as did I, via acquisition last August, when Intel Corporation acquired Nevex Virtual Technologies, which was a small startup in the caching space. Now, we didn't say a lot about the acquisition at the time that it happened, because when we wanted to go out to the market to tell the world that Intel was a player in the cache space, we wanted to ensure that anybody who took interest could actually buy the product. And that is now all wrapped up. We are currently shipping Intel Cache acceleration software for Windows 2.0. That started shipping in December via Intel's channels and is available through all of Intel's distribution and through its support infrastructure. We have Intel Cache acceleration software for Linux coming in February. And part of the driver for the acquisition was to put Intel Cache software together with Intel's data center hardware for an overall solution. And that is available now as well. This is also the first part of an ongoing vision of Intel with cache software to provide more management software for its associated SSD hardware. I've skipped on here the basic benefits of server-side caching. It provides, obviously, high performance and low latency of being on the same servers where the CPU is doing. Instead on here, I've concentrated on a couple messages that are a little bit more unique to how Intel positions the product. So we've taken the problem from the side of application performance, not so much from just blindly accelerating back-end storage. In that, we talk mostly to the app admins or the DBAs in the company. And we sell this in a few ways. One, we pitch how transparent the solution is. You don't have to do anything to the application. You don't have to do any configuration on back-end storage to make the caching work. It sits in the middle and starts automatically generating IOPS for the applications you care about and providing that level of performance. Because we take this from the side of the application, we're pitching to the app admins and the DBAs, and we pitch to them control that they didn't previously have. So previously, if they realized that to keep their queries going at the proper speeds, they needed another 2,000 IOPS, they had to go beg the storage group for that. And everybody else in the organization was begging the storage group for more IOPS as well. With caching, they effectively are creating IOPS locally on the app server itself. And then they have the ability to apply those IOPS to the applications that they care about. But in the same breath, this helps the storage group as well. Because what you're really doing is moving IOPS from back-end storage to the server layer. And that's taking weight off of back-end storage. That's allowing back-end storage to redeploy hard drives that they were over-provisioning for performance to handle upcoming capacity needs, because data continues to double every 18 months. So we ship this or sell this as a win-win scenario. It's not a rip and replace, it's not a disruptive sale, it's not a throw away all the money you've spent on storage in the past. It's add performance with caching and SSD at the server level, make back-end storage more functional, use some of those hard drives to cover upcoming capacity, and everybody wins. Now, everything on this slide is something that a well-implemented cache solution will provide. This is not unique necessarily to Intel. However, slide 5, we start to get into some differentiated technology. There's already caching happening on any given app server in DRAM. The way the operating system works is any memory left over is used to cache data locally, which is exactly what cache software does with SSDs. we wanted to ensure that the solution we provided wasn't duplicating what was already happening in DRAM, but was in fact working cooperatively with the cache in DRAM to provide a best of both worlds, where the most active data is coming back at memory speeds, backed by a much larger cache hit rate or much larger cache on SSD. This is, of course, going to be I/O dependent. If your application is doing lots of random rereads and everything, all the data is the relative same hotness level, for lack of a better description, then this integration is not going to buy you any bonus. However, in scenarios where there are more active amounts of data, where there's white-hot data identifiable in database environment where there are temp tables or indices that are hit constantly, this provides a huge benefit. And the multi-layer cache can drive performance that goes above and beyond what it would look like if you moved all of your data to SSD. Another of our key differentiators is on slide 6. As I said earlier, we take the problem from the side of the application, and that is architected right through the overall solution to the point that, to us, it doesn't matter where the data is stored. It can be in direct attached, SAN, NAS, what have you. What matters is the application that asked for the data, and you can choose which applications you want to accelerate through the cache software, and by extension, everything else is ignored. There's two key advantages to this. One, performance. The information in the cache is more applicable to the applications that you care about, which means a higher cache hit rate, which means higher performance. But equally important, and sometimes even more important, it means that nothing else that happens on the server can affect the data in the cache for the applications that you care about. That's what the charts here show. On the top one, the silver one, we've got an application set up to be protected by Intel cache acceleration software. We've got a relatively small 3-disk SAN, so obviously the caching software in the SSD is driving much higher performance. But then we turned everything else on in the server. All the other applications, virus scans, backups, generated as much I/O as we could back to the SAN. Took the SAN down to 5% of its efficiency. Now, that's an extreme case. If an enterprise can take its SAN down to 5% of its efficiency, they have other problems. But for the purposes of this demonstration, it's perfect. We took the SAN down to 5% of its efficiency. The one application protected by Intel cache acceleration software went from 100% efficiency to about 95%. And that small drop being cache misses that are now going back to an overburdened SAN. So it doesn't just provide additional performance to the application, it protects that performance gain so that you have consistent performance and response times. Now, just before I pass this over to talk a little bit about the SSDs, a couple new things that we've put out since the acquisition. One, we've added the ability to cache to a shared remote SSD. And the reason we did that was in the case of virtual platforms. When you have vMotion running and your VMs move from host to host to host, if the cache is on a local host, then after the VM moves, it has to start caching from scratch on the new host. Well, all that work we did on the previous slide to try and keep the cache efficiency as high as possible and keep performance as consistent as possible kind of goes away if it has to start over every time the VM migrates. So by caching to an SSD on shared storage that can be seen from all of the hosts in the virtual environment, that means that as the VM migrates from host to host to host, caching continues to work during migration, and the cache is always hot no matter where the VM goes. And last but not least, we are bringing out the Intel cache acceleration software for Linux, and that's coming in February. This shipped last summer prior to acquisition through Nevex. This is the first release through Intel, but it's differentiated because Intel is a very strong player in the open source space. And given that, we have made the decision to open source, or GPL, the entirety of the Intel CAS for Linux product. So this will ship in 2 versions, a open source code release, so anybody can grab the code, compile it to their favorite Linux operating system, and they're good to go. And a fully packaged enterprise subscription, which comes as prepackaged binaries for Red Hat Enterprise Linux and CentOS 5 and 6, and SUSE Linux Enterprise Server 11. We may expand that platform base depending on customer opportunity. The enterprise subscription comes with full support and product updates, all as part of the package. So this will come in 2 versions. The Linux product itself is the same on both. So the enterprise version is, or the open source version is not limited in some way. So you can get it as the open source code release or as the enterprise subscription. So with that, as I said, one of the main drivers for the acquisition of NEVEX by Intel is to put this all together as a combination Intel cache acceleration software and Intel data center SSDs to provide the overall cache solution. So to talk a little bit about the SSDs and the solution, I'm going to hand this over to Carolyn.
Thanks, Andrew. My name's Carolyn Hanley. I work in Intel's Non-Volatile Memory Solutions Group, and I'm going to talk to you about 2 of our SSDs that are designed for the enterprise. And they're an excellent complement to Intel's cache acceleration software because they provide high levels of performance, data protection, and endurance. Andrew spoke about the Intel CAS ability to provide consistent application acceleration. We actually have a feature on the Data Center S3700 series. It's our 2.5-inch SATA-based drive, and we can actually deliver consistent performance at the SSD level as well. We're able to deliver very tight IOP distribution with a smaller variability between average and minimum IOPs. And then we also deliver extremely consistent low maximum latencies. So this ensures consistent response times for enterprise applications. So it's an excellent complement to the caching software. In addition, we've also implemented several techniques in the drive to protect against possible corruption. And one of those, we have a power-safe write cache built into the drive. And this is implemented with a power loss imminent detection circuit. So for enterprise customers, during an unsafe shutdown, the drive has the capability to switch over to backup power and write whatever in the cache to the drive before powering down completely. So this provides higher level of protection for enterprise customers. And then lastly, we have implemented something called high endurance technology on our data center drives. And it's a combination of implementation in the firmware, some things we do in the controller, as well as some silicon enhancements in the NAND to extend the write endurance of the drive. So for example, on an 800 gigabyte 3700 series, an enterprise customer could do 10 full drive writes per day over 5 years. So let's go to the next foil, and we'll talk about our PCIe-based drive. And it's Intel's highest performing SSD. It delivers 180,000 random reads and 75,000 random writes. And we believe that it's an excellent choice for server-side caching because of the reduced latency. It delivers data directly to the CPU through the PCI bus. And there's really simplified deployment. This drive can be installed in a server. It doesn't void the warranty. And this drive also has our high endurance technology, which provides 30 times the endurance over our standard endurance drives. So let's talk about our joint value proposition. So Andrew mentioned that it really is all about the solution. We're very excited in NSG to have a solution that delivers additional value for our customers. And one of the things that we feel is a good value for our enterprise customers is with this caching software, they don't have to replace all of their existing storage, so they can get SSD levels of speed without a total data migration cost. And we're hearing a lot from our enterprise customers that they want performance, but they don't want it at the cost of data integrity. And our solution delivers both with at the software level with read with write through to maintain that consistency between the cache and backend storage to help preserve data integrity, as well as on the SSDs with the end-to-end data protection and our power loss protection.
Well, thank you for that, Carolyn. You know, I'm really intrigued by this idea of server-side caching, and my first question for you guys is, do I need to do something special to my apps? Do I need to recompile or do anything like that?
That's an excellent question. And no. So the software itself, you can go into the software UI and tell it what applications you want to accelerate and which ones you want to ignore. But there's nothing you have to do on the application side itself. You don't have to tell the applications that caching is in place. And in fact, you don't have to tell backend storage either. The cache software just sits in the middle, will move whatever it sees as, or copy whatever it sees as active data to the cache on SSD, and then serve it from there. So you'll get the performance benefit without having to do any configuration.
And then, Andrew, you talked about how it could do this in a consistent manner, give you that consistent, reliable, same levels of high performance. How is it able to do that without jitter?
Oh, yeah, that's another good question. Generally speaking, we do it on the data that's being accessed by the application. Mm-hmm. In some cases, we have enough knowledge to go a little bit deeper. For instance, in Microsoft SQL Server, we can cache or ignore down to the database table level. And that's really important. Look at a deployment where someone's got a transactional database and a historic database running in the same instance. What they care about is that the transactions run as fast as possible, because that's running the financial fabric of the business. The historic database, you might be running nightly or weekend reports on. It doesn't matter if they run in 6 hours rather than 4. They're still done in the morning. And if it read a half terabyte of data in to run that report, in a normal cache, that would have washed out the entire cache, and the next morning your transactions are back to slow again while it rebuilds the cache data. In our scenario, that is completely ignored by the cache. The next morning your transactions are running as fast as they possibly can.
And then kind of a hardware question, maybe for you, Carolyn. Is it, when you plug this SSD into this server-side caching, is there an optimal kind of node you would use the SSD in? Is it be a fat node, something with a lot of memory, or what would that look like?
Well, it would depend on the implementation, but if your application had a higher level or a larger active data set, mm-hmm. you could deploy multiple SATA-based drives or multiple PCIe-based drives and RAID them together as a single cache layer.
Sure. So, and then you mentioned this interesting, given that the Super Bowl power went out last night, halfway through the game, this power safe test, and I'm wondering, is that something unique in the SSD world, or is it something that came over from the spinning Rust side of things?
It's unique in the SSD world. Different vendors implement it in different ways. We've implemented it by implementing this PLI, or power loss imminent detection circuit, and it really provides enterprise customers the capability that they know that their data is going to be protected, from the time it enters our drive to the time it leaves. And we also validate the condition of that detection circuit on a periodic basis to make sure that it's working properly, so that the enterprise customers know that if there is a power outage, anything that's in the cache of the drive is going to be written before it powers down completely.
Terrific. Well, kind of a wrap-up question here, guys. I mean, how disruptive is it to kick the tires on this and set up server-side caching? Is it something that you can do baby steps and do a test case, or do you really have to go in with both feet?
That is a brilliant question. And it's actually really easy. So all you need is SSD added to the server or used on shared storage. To install the cache software, there's a free trial that runs for 30 days, and there's nothing you need to do other than register online. And it installs in about 7 clicks of a install wizard, and it goes from there. So you should be able to evaluate the advantage it has on your applications very easily.
And just to double check, this is shipping now, correct?
This is shipping now. The Windows product is out and about, and the Linux product will be mid-February.
Terrific. Well, Andrew and Carolyn,